we're going to learn how to find the particular integral of linear differential equation of this form, whereas the right hand side function, that is non-homogeneous function, is of this form, that is exponential into some function of x. In particular, this function is either polynomial or maybe a sine or a cos. In that case, first we will write the operator form of the given differential equation. After that, in order to evaluate the particular integral, we will write in this form, and then we replace d by d plus a, where a is the coefficient of x in the exponential. With this, we will take the exponential term outside to this operator form. And then this operator form is only applicable for the function of x. Let's understand this case with the help of example. First case is find the particular integral of this differential equation. Now in this case, how to find the particular integral? So ypx is evaluated as, take this term in the denominator as 1 by fd form. So we can write this is 1 upon d square plus 2d plus 5 e raised to power minus x cos of 2x. Now, first step, we need to replace d by d plus a in this case, because in this case it is the combination of two functions. One is the exponential and second is the cos. So in this case, what is the value of a? A is basically a coefficient of x in the exponential term, that is the minus 1. So we will replace d by d minus 1 because the value of a is minus 1. So we have 1 upon d minus 1 square plus 2 d minus 1 plus 5. Whenever we are writing this form as d replaced by d minus 1, in that case, we will take this exponential term outside from this operator form. So we will write this is equal to e raised to power minus x, then operator form where d is replaced as d minus 1 into the second function, that is the given as cos 2x. This is equal to e raised to power minus x. Denominator term is now, it is d square minus 2d plus 1 plus 2d minus 2 plus 5 cos of 2x. Simplify this. So minus 2d plus 2d, that will be cancelled out. Finally, we have e raised to power minus x 1 upon d square plus 1 minus 2 plus 5, that is equal to plus 4 cos of 2x. Now the particular integral is evaluated with the help of this expression, that is the cos 2x. In this case, we are replacing d square by minus a square, where a is a coefficient of x in this term, that is the cos 2x. What is the coefficient of x in this case? That is the 2. So we will replace d square with minus 4. For more details how to find the particular integral in case of sine and cos, the link is given in the description. Now when you replace d square with minus 4, we have e raised to power minus x into 1 upon minus 4 plus 4 cos of 2x. It is getting a 0. It means it is a case of failure. In that case, rather than taking a function of d, we will take its first order derivative. We write in this case e raised to power minus x 1 upon derivative of function with respect to d is 2d cos of 2x. But there is an additional term, as we have taken the first order derivative. So we multiply this one with x by, so we have e raised to power minus x upon 2 1 by d cos of 2x. Now 1 by d stands for the integration. So we have e raised to power minus x into x by 2 integration of cos 2x with respect to x. So finally we have ypx is equal to e raised to power minus x into x by 2. What is the integration of cos 2x? That is the sin 2x divided by 2, and that is the final answer in this case. Let's answer the next question. This is a similar type of a question, and the right hand side function is exponential into sine. So first we write its operator form. This is the second order derivative. This is the first order derivative. So we will replace these terms by d square y, and this is a dy. After that we will collect the coefficient of y. So this is the function of d. Now for the particular integral, we take this function in a denominator on the right hand side, and observe that there is a two terms. One is exponential and second is the sine. So first we will operate exponential term. In that case we need to replace d by d plus a, where a is a coefficient of x in the exponential term. So what is the coefficient of x in this case? That is the 2. So we replace d by d plus 2. So finally we have 1 upon d plus 2 square minus 4d plus 2 plus 13 sine 3x. Now what about e raised to power 2x? That we will keep outside from this operator form, because the role of exponential is only to replace d by d plus 2. Simplify this, we have e raised to power 2x. So this expression is d square plus 4d plus 4 minus 4d minus 8 plus 13 sine of 3x. So finally particular integral is equal to e raised to power 2x 1 upon d square. This term is get cancelled with this one, and that is equal to 9 into sine 3x. In case of sine and cos, we replace d square by minus a square, where a is a coefficient of x in sine or a cos. So in this case the coefficient of x is 3. So 3 square is 9. So we replace d square by minus 9. So finally we have e raised to power 2x 1 upon minus 9 plus 9 sine 3x. So this is a case of failure because it is getting a 0 in a denominator. So in case of failure, we are taking the function fd. This is a new function fd. We will not take the previous function. So in this case, the function fd is d square plus 9. So take its first order derivative. So we have 1 upon 2d. These two terms are as it is e raised to power 2x and sine 3x. But we take additional term in this case since we are taking a first order derivative. So we multiply this operator with x. This is equal to e raised to power 2x into x. So 1 by ds get converted into the integration of sine 3x with respect to x. This is further is equal to e raised to power 2x into x by 2. Integration of sine is minus cos of 3x by 3. Final particular integral in this case is equal to minus e raised to power 2x into x cos of 3x divided by 2 into 3 is 6. Let's answer the next question. Rather than now it is a sine or a cos, we are dealing with the polynomial product with the exponential case. So write its operator form. Operator form is d square y minus 4y is equal to e raised to power minus 2x x square. Collect the coefficient of y. So we have d square minus 4 is equal to e raised to power minus 2x into x square. So for particular integral, we can write it as 1 upon d square minus 4 e raised to power minus 2x into x square. So first we will operate the exponential. So in this case, d is replaced as d plus a, where a is a coefficient of x in the exponential term, that is minus 2. So d is finally replaced as d minus 2, and we will take this exponential term outside. Then we have d minus 2 square minus 4 in a denominator, and second function of x is as it is, that is the x square. This is equal to e raised to power minus 2x 1 upon d square minus 4d plus 4 minus 4 x square. So plus 4 and minus 4 will get cancelled out. This is equal to e raised to power minus 2x 1 upon d square minus 4d into x square. So ypx is equal to e raised to power minus 2x. How to find the solution in this case? So we are creating a 1 plus or 1 minus form. So we need 1 over here. So we take the lowest power of d outside along with its coefficient. So lowest power of d is d raised to power 1. What is its coefficient? That is minus 4. So take this complete term outside. We have 1 upon minus 4d into, so d square by minus 4d, that will get converted into the plus 1 into x square. Next, take this term in a numerator. This is equal to e raised to power minus 2x. So minus 4 we are taking outside because it is a constant. 1 by d, that is 1, plus minus is a minus. D square by 4d is d by 4 minus 1 into x square. So this is equal to minus e raised to power minus 2x by 4 1 by d. Expand this. So this can be expanded as 1 plus d by 4 plus d by 4 whole square plus d by 4 cube and so on. Now the point is how many terms we need in this case. So we have the function as a x square. Its third order derivative is 0. So if you observe, derivative of x square is 2x. Second order derivative of x square is 2. And its third order derivative is 0. So there is no need to take the third order derivative term along with higher order derivatives. So we can write this is equal to minus e raised to power minus 2x by 4 1 by d 1 into x square, that is x square, plus d by 4 into x square plus d square by 16x square. There's no need to write the next term because it is a getting 0 when operator on x square. This is further is equal to minus e raised to power minus 2x by 4 1 by d x square. Its derivative is 2x by 4 plus second order derivative of this term is 2 divided by this 60. Now this is equal to minus e raised to power minus 2x by 4. 1 by d stands for the integration. Now we need to take integration of all these three terms. So integration of x square plus 2x by 4, that is x by 2 plus 1 by 8 with respect to x. So final answer in this case is minus e raised to power minus 2x by 4. Integration of x square is x cube by 3 plus integration of this term is x square by 4 plus integration of 1 by 8 is x by 8. And that is the final answer in this case.